All right. For today, we're going to talk about P53 overexpression and how it might be used in qPCR and Western blot. These are just some keywords I have up to help me remember the questions and in what order to go over them. So the main focus of today is overexpression of P53 in 293 T cells. The first part examines using qPCR and the reagents involved in it. You will need a primer, nucleotides along with polymerase, cDNA, reverse transcriptase, and a fluorescent dye. The primer is used to begin the process, and we'll begin the process of the DNA splits and making the cDNA, which can later be used in qPCR or the PCR. The polymerase will come with the nucleotides, and through reverse transcriptase, it will make cDNA from the mRNA. And the fluorescent dye is used to visually determine the quantity of the P53 cDNA in the tubes at the end. What we might expect to see is in the tubes containing the overexpressed P53 compared to a control that we might use, we should expect to see a increased quantity as well as more fluorescent dye activity in the one with P53 overexpression than when compared to a control. You can also use a Western blot analysis to determine the levels or the quantity of nucleotide strands or the level of the protein. We'll create 3 wells, a DNA ladder, our transfected cells, the ones with increased P53, control, and the use of the ladder is to help give a visual placement for the rest of the sequences because we already know the existing values of this. And just to put numbers on it, perhaps 20, 30, 40, length of nucleotide pairs. So it'll give us a size when we do it. And the DNA ladder is already made for us, so we'll know that the values of each of these when it comes out. In order to create the antibodies for this, we will first need P53 in 293 T cells, and this is considered the antigen. So in order to create the antibody, we will first use a mouse and inject it with P53. This will be called mouse anti-human P53. And this is considered our first or our primary antibody. To then make our secondary antibody, we will use goat anti-mouse P53, and this will create our secondary antibody. And the way these antibodies work is that your primary antibody will bind directly to the sequence, and then your secondary antibodies bind on top of that first antibody. Also, in the secondary antibody, along with the process, you will also add a horseradish fluorescent dye. And what this will do is it will make any area with highly concentrated antibodies glow a lot brighter than a counterpart that does not have the overexpressed P53. what we might expect to see now is that in this overexpression of P53, some rather large and bright bands where overexpression is present, compared to a control we might not expect to see as bright of a occurrence.